Okay, so now we're going to look at what's called empirical formulas. And this is the simplest whole number ratio of atoms in a compound. So when I look at your flip notes, I'm going to want to see that you have not only the steps that are on the next page, but you've worked out all of these sample problems, because this is going to be key to you having notes to go back to when we're solving these problems. So you need to first obtain the mass of each element present. And so you have to see how many grams you have of these elements. So you're going to go through these steps and write this down, and then we're going to go through several examples. You're going to determine the number of moles of each type of atom present. You're going to then divide the number of moles of each element by the smallest number of moles to convert the smallest number to 1. So you're going to go ahead and figure out what our ratio is based on moles. And then, if needed, multiply the numbers you derive by the smallest integer that will convert all of them to whole numbers. This set of whole numbers represents the subscripts of the empirical formula. Gosh, that sounds like a lot of things to have to understand and follow, but really the steps are quite straightforward once we get to the problem. So make sure you have these 4 steps in front of you. And then, from there, we can follow these problems. So your first problem says an oxide of aluminum is formed by the reaction of 4.151 grams of aluminum with 3.692 grams of oxygen. Calculate the empirical formula for this compound. So our first thing told us to obtain the mass of each element present, and we have that. So we have 4.151 grams of aluminum, and we have 3.692 grams of oxygen. Step 2 says, determine the number of moles of each type of atom. So, grams to moles, I want to get rid of grams. Grams goes on the bottom, moles goes on the top, and same here, grams goes on the bottom, moles goes on the top. I always put 1 in front of moles, and then I'm going to put my gram formula weight in, 26.98, and this one is 16.00. And then I go ahead and solve. And in this case, I get 0.1539 moles of aluminum. And here I get 0.2308 moles of oxygen. My third step says to divide the number of moles of each element by the smallest number of moles. So my smallest number of moles is 0.1539. And I'm going to divide by 0.1539 moles. So something will always be 1. And then when I divide this one, I end up with 1.5. So I can't have 1.5 of an oxygen. What's 1.5 of an oxygen? So I have to do step 4. If needed, multiply the numbers you derive by the smallest integer that will convert all of them to whole numbers. This set of whole numbers represents the subscripts of the empirical formula. Very often it's 2, sometimes it's 3. For me, the easiest way to see what I need to multiply by is to turn this into a fraction. So 1.5 is actually 3 over 2. And so I'm going to multiply both of these by 2. So times 2 equals 2. Times 2 equals 3, which is the same here. That would also equal 3. And my formula is going to be Al2, because this is the 2, O3, because this is the 3. Bonus is that if it's a formula, we know it's going to be written correctly. It's not going to be something that's written incorrectly. Let's take a look at another one. When a 0.3546 gram sample of vanadium is heated in air, it reacts with oxygen to achieve a final volume of 0.6330. Calculate the empirical formula for this compound. So, I have my grams. First is to find my mass of each element. So I have 0.3546 grams of vanadium. That's good. But I have the final volume, and I know that it's reacting with oxygen, so I need the mass of oxygen. So I actually need to do a little subtraction problem, which I'll do up here off to the side. I need to do 0.6330 grams minus 0.3546 grams. So I'm going to do the grams of my compound minus the grams of vanadium to get 0.27. I guess 0.2784 grams of oxygen. 0.2784 grams of oxygen. There's my first step. Now, determine the number of moles. Grams vanadium, moles vanadium, that's going to be 1. Grams oxygen, moles oxygen, and again that's going to be 1. This is 16.00, and when I solve that I get 0.01740 moles of oxygen, and this is going to be 50.94 for the gram formula weight, and I get 0.00696 moles of vanadium. Step 3 tells me divide through by the smallest number. Well, 0.00696 moles is my smallest number, and I get 1, and 0.00696, and I get 2.49, which is really 5. Okay, which is really 2.5, is what I'm saying. If I double this again, this ends up being 2. This ends up being 5, and my formula ends up being V2O5. And then let's try another one. In a lab experiment, it was observed that a sample made with lead combines with a sample of chlorine to form a binary compound. Calculate the empirical formula for this compound. This compound is 74.5% lead by mass and 25.5% chlorine by mass. Well, we're giving the information, the percentages now, but let's assume always that we have 100 grams of the substance. Well, now that's telling me that I have 74.50 grams of lead, and I have 25.50 grams of chlorine. Now I'm up to my same step. Okay, I need to convert to moles. So grams of lead goes on the bottom, moles of lead goes on the top. It's 207.2, so here I get 0.3596 moles of Pb. Chlorine, I have to do the same thing. Grams of chlorine goes on the bottom, moles of chlorine goes on top. 1 mole of chlorine, 35.45, and I get 0.7193 moles of Cl. Well, what's my next step going to be? Well, if you said divide by the smallest number, you were right. I'm going to divide by 0.3596 moles. And divide by 0.3596 moles. This ends up being 1, and this ends up being 2. And I end up with PbCl2. 2 for my Cl, 1 for my Pb. And so now, my last one, it's not any harder, it just has a little more steps. A sample of lead arsenate, an insecticide, is used against the potato beetle. It contains 1.3813 grams of Pb. It contains 0.00672 grams of hydrogen. It contains 0.4995 grams of arsenic. And it contains 0.4267 grams of oxygen. I have my grams. It doesn't change anything that I have 4 compounds. It's just a little more division. So again, I'm going to convert all of these to moles. Grams of Pb, moles of Pb. Grams of H, moles of H. Grams of arsenic, moles of arsenic. Grams of oxygen, moles of oxygen. 1, 1, 1, 1. My lead is 207.2. and that ends up being 0.00667 moles of Pb. 1.01 ends up being 0.06653 moles of hydrogen. If we round these too much, sometimes it makes our answers a little tricky. We want to make sure we have our right number of significant figures. This is 74.92, and this is 0.006667 moles of arsenic. And here we have 16.00, and we have 0.02667 moles of oxygen. Well, my smallest one is this 0.006653, so 0.006653, 0.006653, 0.006653, 0.006653. Go. This one's the obvious one. This is 1. When this one divides, this one's also 1. And when this one divides, this one's also 1, even though they're all slightly a little bit different. And then when this one divides, it's 4. And those are all whole numbers, so I don't have to do any fancy multiplying. I'm just going to write them in order. PB1, H1, AS1, O4. And that would be my formula. Okay, so we attacked the same type of problem using the same 4 steps. We saw some different things in each one, indicating that we have percentages or we have more than one compound, but they're all essentially the same. And that key step of converting grams to moles is what is very important.